Sound can be defined as vibrations that travel through the air or any medium and can be heard when they reach humans or animal ears. Noise is defined as any unwanted sound. Decibels are the unit of measurement for the power of a signal, such as an electrical signal or sound, compared to some reference level. Sounds of 70 decibels or less are generally considered safe, and any sound at or above 85 decibels is more likely to cause long-term hearing damage. A healthy young person's normal hearing frequency range is around 20 to 20 Hz. However, the normal audible loudness range is 10 to 180 decibels. Excessive noise exposure is hazardous for children and babies. Their ear canals are not fully developed, and their auditory faculty is more sensitive than adults. The safe decibel level for babies to sleep is around 50 to 60 decibels. Higher decibel levels are considered harmful to a baby's sleep and can impact their sleep quality, sleep pattern, and development. As time passes, many musical toys for the babies and children are produced to improve cognitive skills and sensory development. Nevertheless, many toys can produce noise levels as high as 85 decibel, which will undoubtedly affect the kid's hearing sense or worse, hearing loss after prolonged exposure.
Hello and Assalamualaikum. My name is Muhammad Muasazi bin Maurad. According to Richard E. Burke, the quality of sound waves should be the starting point for any study of sound. F.J. Fahey, in order to interpret sound pressure level data in terms of energetic quantities, power intensity, and energy density, and to quantify associated errors. All these methods implicitly assume some idealized form of sound field produced by radiation from a source. If it could be based upon widely available field measurement equipment like the condenser microphone or portable sound level meter, such a technique could help overcome some of the difficulties in making power estimates for large industrial source. In 2017, Augustin Catalin found that the sound level meter, which measures sound pressure level, is employed for sound measuring. Due to the rotational component, there are particular frequencies in noise measurement and analysis.
Our objectives for this group project are to compare the sound level of the toys by using software and device which is sound level meter, and to calculate the accuracy and error of the measurement. Meanwhile, the methodology is quite similar to the previous open-ended lab procedure, which uses 5 types of toys. Then the toys are put 2 meters away from the sound level meter. The noise is recorded for 30 seconds by using a stopwatch, and the procedure is repeated with the other type of toys. Then the steps are repeated again with the distance between toys is now reduced to 0 meter from the device. And lastly, the data will be tabulated accordingly with the maximum and minimum value of sound level. This is the apparatus used, which is the same with the open-ended lab, with 5 different types of toys and measuring tape and sound level meter.
Next, I'll be talking on the results. In order to achieve our objective, which is to compare results obtained using SPL meter and Audacity with the MATLAB, we do the comparison by inserting all the data into tables and generate 4 graphs. And from the graph, we can clearly see the maximum, minimum, and mean value for each toy. Next is the calculation mean value. This is the mean value of toddler maracas for 0 meter and 2 meter, where 76.57 is for the 0 meter and 63.2 for 2 meter. Next, we move to the percentage difference, which also one of our objectives for this project. For this part, we generate 2 graphs in order to know the percentage difference for 0 meter and 2 meter. And from this graph, we can know the range of the percentage difference of sound measured by the SPL meter and Audacity with the MATLAB. Lastly is the calculation for percentage difference. This is the percentage difference of toddler maracas for 0 meter and 2 meter, where 47.57% is for the 0 meter and 35.35% for the 2 meter. That's all from me. Thank you.
For discussion part, which one is better, sound pressure level meter, SPL or Audacity? Based on theory and fact, sound pressure level meter (SPL) is a device that has high accuracy and is more precise compared to Audacity software. It is because Audacity uses devices such as laptop microphone to record and receive the signal, and it might be effect from the outside environment source. Meanwhile, for the SPL, it uses microphone that combine the precision and stability and reliability to measure data accurately. Next, the International Standard Organization (ISO) Technical Committee recommend that close-to-ear toys should not exceed 65 decibel when measured in the free field, and all other toys should not exceed 85 decibel. So from our data that we get here, the table, we can see that using the SPL and using the Audacity, both the result that we receive, none of the toy exceed the international standard. So we can say that all the toys that we measure follow the International Standard Organization recommendation. Next, during the experiment, some of the error that may occur is systematic error due to environmental and instrumental error, and gross error and random error. So in order to prevent it, we need to calibrate the instrument against the standard and take proper care in reading and recording. Last but not least, we need to select suitable environment to conduct the experiment.
In conclusion, MATLAB software was used to calculate the mean, peak, maximum, and minimum sound level of audio signals recorded using the Audacity application. SPL meter grabs information directly from the screen. The difference between these two programs led us to conclude that SPL meter recorded a lower sound pressure level than Audacity. That's all. Thank you.